Hello geometry students, this is a video for example 3 for geometry topic for lesson 6. Prove that two triangles are congruent. We've been doing this a bit, but I think we have a more complicated diagram now to deal with. Write a proof to show the triangle BFE, this one inside here, is congruent to triangle CEF. It's given that AB is congruent to CD and AF is congruent to ED and angle A is congruent to angle D. So let's look this over and see how we can get certain pieces to be congruent, right? We need to have three pieces congruent and a certain three in those two triangles. Number one, I can see there's an overlap. Segment FE is congruent to segment FE because it's the same segment. What else do we have out of that side? Do we have that side? We could, because triangle BAF and triangle CDE are congruent to each other because of side angle side. And once these two triangles are identified as being congruent, we can say certain parts, corresponding parts are congruent. So we could say CE is congruent to BF. Okay? So now I have two sides. All I need is this angle inside, right? Because then I could go with side, angle, side. How could we do that? I'm thinking I can say this angle here, BFA, is congruent to this one here, CED, because their corresponding parts are congruent triangles. And then I forget what the names of the postulates are or whatnot, but because this is a straight angle, I can subtract 180 minus that one there to get this one here, and eventually have those two angles are the same. Sorry, I'm not using professional lingo. Your teacher will probably do a better job than me. Moving on. Let's see what they wrote for a solution. Given that, that, and that by the segment addition postulate, since AB is congruent to DC, and angle A is congruent to angle D, angle ABE. Oh, they went with triangle ABE. I didn't even notice. ABE. They jumped right over to that one. All right, they went to that. There are multiple ways to complete a proof. How could you use side-side-side triangle congruence in this proof? That's just a challenge because I think they're going to solve it not using side. So their proof was going a different route than mine. So let's see what else they have. After using this big triangle here, notice it has this side in the triangle that we need to eventually prove is congruent, and we have the common side. This means by CP-CTC that BE, like I just pointed out, is congruent to CF, and angle BEA, oh yeah, so it had a double whammy. It also had that one there. So kudos to them for finding two triangles congruent that had two parts that we could use in our final solution. Therefore, by side angle side, you can eventually have the two triangles that we were trying to prove be congruent. Okay, let's see another one. Write a proof to show that triangle SRV, I got a lot of markings in these triangles. It's congruent to TUW. And you can see from the markings, it's a right triangle. So I'm thinking maybe I'm going to use hypotenuse leg. Whenever I see right triangles, I think about hypotenuse leg. Here's a side to another side. There's a little angle up there. There's a little angle up there. There's an angle down here. Holy smokes. So, click pause, give it a shot. If you want some hints, maybe after I give a hint or two, you could click pause and then try to finish it the rest of the way. I would start with trying to identify the two triangles we're trying to come up with, SRV. So we have that bit there. And how many pieces of SRV do we already know? are congruent to triangle TUW. That's one way I would start. I can see a side and a right angle. All I really need is the hypotenuse now. So I look at the hypotenuse, and I wonder how I can prove that hypotenuse is congruent to that hypotenuse, because then I'll have hypotenuse leg. We have this angle here. We have this angle here. We haven't used these little, I mean, they usually give us certain information that's going to help us in the end. I think I see a way that I can get this length to be congruent to this length. Okay? Click pause if you want to give it a shot. I'm ready to start. Well, I think I'll just go, their answers in paragraph form, so and that's the way I'm kind of talking, so I might as well just go right to theirs. While I read, I'm going to try to identify on this here. Given SR is congruent to TU, and angle SRW and angle TUV are right angles, angle SWT is congruent. So given, are they just telling me all the given stuff? They are. Oh, that's the given and that's the proof. That's embarrassing. I'm not going to re-record this. We're just going ahead. Since SWT is congruent to TVS, that's right here, to TVS, that's this angle here, and ST is congruent to ST, which is this up here, and this little angle here is congruent to that little angle here. By angle side, we can say SWT is congruent to TVS, okay? Because we have an angle, and the common side. We have an angle, and the common side. Once you do that, by using CP/CTC, you can say segment SV is congruent to segment TW, and then the rest of it's pretty much what I was describing. We have a right triangle with a side and a hypotenuse congruent to a right triangle with a side and a hypotenuse. Okay? After all that, you should be able to do problems 13, 21, 22, 24, and 28. That's it for this video. Have a great day.